Good morning, friends. This is Professor Chaubey. Professor Chaubey has finished class. Professor A.k.chaubey now doing some problems on electrical measurements. So, I have here one problem. The current I in the electric circuit shown is, this circuit is shown here that 2 ampere current is coming from this side, there is junction here, and 2 ampere current is coming from this side, then current is going here, and then 1 ampere going in this arm, and 1.3 ampere going here. What is the current coming here? Just simple, you apply the current law, current addition law. So find out current I, whether I have 4 options, what value of the current I is. So friends, see, 2 ampere current here, 2 ampere current here, so here total current becomes 4 ampere. Now 4 ampere current here, at this junction 1 ampere goes this side, so current left here is now 3 ampere. Now current going at this junction is 1.3 ampere, so out of 3 ampere, 3 minus 1.3 goes this side, so what current in this arm? Obviously 3.0, 1.3, 1.7 ampere. So the answer of this simple question is 1.7 ampere means 4. Part 4 is the correct answer. It's simple. Addition of current or subtraction, whatever current, any junction, there is no accumulation. So total currents are, summation of current is 0. At this junction, at this junction, at this junction. Or ingoing current is equal to outgoing current. So you apply Kirchhoff current law and you can solve this. Just applying Kirchhoff current and nothing else. So this is the correct answer of this problem. Now similarly I will try to solve some other problems. I will do some other problems. Say I have a figure resistance here, and here 3 ohm resistance and 2 ampere current here. 2 ampere current flowing here, and this is 3 ohm resistance here. And then I have a battery or a cell here, positive here, negative here. And then this is 1 ohm resistance. 1 ohm resistance. And in the circuit I have here point B, this is point A. This circuit here, this is 2 volt battery. The problem is, in the circuit shown here, find in the circuit shown above, find out VA minus VB, the potential difference BA and BB. What is the potential difference? This is the question. And the answer choice is 8 volt, and second is 6 volt. This is minus 8 volt. This is 6 volt, and then 10 volt. Fourth is 3 volt. So I have this circuit here, current flowing 2 ampere in this circuit. Remember the current direction and the potential is their opposite. Or you can say that the potential, whatever EMF source, is equal to the IR drop. You apply the Kirchhoff voltage law. So IR drop here, IR drop here. And write the equation. I is 2 ampere here. So 2 ampere into 3. So 2 3 are 6. And 2 ampere into 1. This current is same. So it is 2. So 6 and 2. And the battery is opposite. So what will be the total? Because this is current flow here is such that potential drop, potential is decreasing this way. So I think you have to add all the potentials because it is opposite. So minus like that, or means all potentials are of same type. So potential means VA minus VB. What the potential drop here? What the potential? We measure potential. These two. So you write. You can write the equation. See, 2 ampere into 3. 2 into 3. The same direction. And plus 2 into 1. And plus this voltage, 2 voltage. So 6, 8 and 10. 10 volts. So this answer number 3 is correct. Voltage between A and B is voltage drop here, and since this is current and the battery are opposite, if this is say, so this will be added together. That is the 2 volt, 6 volt, 2 into 3, 6 volt here, 2 into 1, 2 volt here, and 2 volt. So 6 plus 2 plus 2, 10 volt, this will be correct answer. So number 3 is the correct answer. Now next I want to do is, with the potentiometer, null points are obtained. With the potentiometer, null points are obtained. Potentiometer null points are obtained at 140 centimeter and 180 centimeter. At 140 centimeter and 180 centimeter with cells of EMF 1 volt with cells of EMF 1.1 volt and one of unknown value. So there are two cells, one is of 1.1 EMF volt, other is unknown, and we compare the potential on the potentiometer wire and we get the null point at the length 140 and 180 centimeter. The unknown EMF is, find out the unknown EMF is how much? There are four options. 1.1 volt, other is 1.8, 1.6, and another is 1.41. That is the fourth one. So it is simple. If you understand the potentiometer principle, that we use a main battery circuit where we apply a voltage on the whole wire of the potentiometer, and then the potential gradient is produced. According to potential gradient, that means potential difference per unit length. If you compare the potentials, we get the length of the neutral point proportional to potential. So the length for 1.1 volt is 140, 1.1 volt, and 180 is for the other. So obviously we know that it is more length than this. So answer from this will be more. The answer of unknown voltage will be 1.1 more than this. So here it is 1.1, it cannot be there. Here it is 1.8, here it is 1.6, here it is 1.41. All three are more than 1.1. So we don't know which is the correct. We have to find out. So we take the ratios of EMF, say E1 upon E2 is equal to L1 upon L2. The simple principle of potentiometer. So E1 upon E2, E1 1.1, E2 is unknown, is equal to L1 140 divided by 180. So E2 is equal to simply 180 into 1.1 upon 140. Thus you can see now. So just 9.9 by 7. So just 7 when you're 7, 2, 1 carry, so 7 when you're 7. So the answer is 1.41 volt. So it means the answer number 4 is correct. So this is simply we use the principle of potentiometer. What the potentiometer principle is? That you generate a potential gradient and then compare the potentials on the wire length. So length of the wire neutral point is proportional to the voltage of the cell. So that way we get the E1 upon E2 is L1. So this is just, we are using principle of potentiometer. Now we are having another a resistor of 5 ohm is connected in the left gap of emitter bridge. Next question means that is the question number 4. A resistor of 5 ohm is connected. The resistor of 5 ohm is connected in the left gap of meter bridge. Of meter bridge. Now, and 15 ohm in the other gap. There are 2 gaps, just beat Stone-Bell principle. Now, the position of the balancing point is position of balancing point is say 25 centimeter 15 centimeter, third is 60, fourth is say 75. So you know meter bridge principle is same as the Wheat-Stroudsburg principle. So we have one gap. In the one gap we connect the resistance of 5 ohm. Then we have another gap. Here we connect resistor of say 15 ohm. And say this is the main circuit here, that this is a meter bridge wire. This is the point here, and this is the main circuit is here. Battery through resistor, key. So now, and here we connect say from this a galvanometer, and the other end is the variable. So this end we get this simple meter bridge, just two gaps here, and the ratio of this resistor and this is equal to this resistor to this. So this is L1 and this is say L2, or simply 100 minus L1, you can say. You got to bring meter bridge. So this ratio is equal. When this is balanced, means for resistance we have P over Q is R over S. That is the Wheat-Stroudsburg principle. So here we have, now they are asking that where will be the null point here. There are four answers. Means at 25 centimeters from here, or 15 centimeters from here, or 60, or 75. Where it will be? That we have to see. But remember that L1 and L2 will be proportional to this, to the resistor. Means what is the resistance in this unknown? This upon the ratio, and this upon this will be this upon this. So we have 5 upon 15 ratio will be L1 upon 100 minus L1. The simple principle of Wheat-Stroudsburg. From this you get 100 minus L1, 100 into 5 minus 5 L1 is equal to 15 L1. Now you have L1 same size. So 20 L1 is equal to 100 into Y 5.5. Yeah, 5 into 100 minus 5 L1. So this 5 L1 goes this side, so 20 L1, and this is now 500. So this is say 500, 5 into 100. Yes, 20 L1 is 5 into 100. Find out. So L1 is equal to 500 upon 20. The answer is 25. Means the null point, neutral point will be from this. If this is the end A, this is also A, and this is a B, this is also, this is a C, so, and this is a C also this. So C, A is battery connected, and B and D galvanometer connected. This is point D. So the null point is from here is simply equal to 25. So at 25 centimeters we will get neutral point. So 25 means this. So this is not correct, this is not correct, this is not correct. Simply one is correct. Because the ratio of this and this must be ratio of this y and this. That is the principle of meter. So answer of this is 25 centimeters. That is the first part. Now next we do some more questions. In the potentiometer experiment, it is found that in a potentiometer experiment, it is found that in the potentiometer experiment, it is found that no current flows through the galvanometer when the terminals of the cell are connected. No current flows through galvanometer when the terminals of the cell are connected across 52 centimeters of potential Y. When terminals of cell are connected, when terminals of cells are connected across 52 centimeters of across 52 centimeters of potentiometer Y. This is the connected. If the cell is shunted by a resistance of 5 ohm, is the resistance, shunt resistance. The balance point is found at 40 centimeters. At the 40 centimeters. The internal resistance of the cell is is 2.5 ohm, 1.5 ohm, 3 ohm, 4.5. So you have to find out the internal resistance of the cell. That you have the, internal resistance. First we compare the EMF of cell directly, that we get EMF. Then we shunt the resistance so some current flows through that and we measure the potential. So then these two, we get the result that internal resistance R is equal to E minus V upon E minus V upon V into R, where R is the shunt resistance. So just we find E and V are proportional to length, or you multiply by potential gradient. So directly gradient will be cancelled, so you have length. So R is equal to E minus V. One is 52, other is 40. So 52 minus 40 upon 52, and shunt resistance is 5 ohm. So this is the answer of internal resistance. Find out, very easy. 12 upon 52 into 5. So that you have to calculate. 60 upon 52. So 60 upon 52 is the internal resistance. Is it right? Or some mistake? 52 and 40. So 52 minus 40. E minus V upon what I have done. This is wrong. E minus V upon E. No, it is not. E minus V upon B. So this should be 40. B. So this is now 1.5 1.5 ohm because resistance. So 1.5. The second part is the correct answer. That is E minus V upon B. So this is proportional to E, length L1 minus V, length 2, or this is B, so this is length 2. So 52 minus 40 upon 40 into 5 is R. So just apply a simple formula of the internal resistance and you get the answer 1.5 ohm. Some more questions I have. For what value of the unknown resistance X for what value of the unknown resistance X, the potential difference between B and D will be 0 will be 0. The circuit is shown here. I show the circuit. It is 12 ohm resistance here. A and B. And this is here 1 ohm and 1 ohm in parallel. One ohm and 1 ohm in parallel, and then this is a C, and this other arm 1 ohm in parallel. G and 6 ohm in X. X and 6 ohm. And this is the battery circuit. So this is the, should be again V-distance bridge. 4 resistors are connected like this. Now what should be X? So that potential B and D will be 0. B and D, the potential difference here, or if we connect galvanometer here, where no current, or B and D are at same potential. So find out X. It means bridge is balanced. Bridge is balanced, then the ratio of this to this, the ratio of this to this equal. This is also 1 and 1. 1 ohm and 1 ohm. So you can find out what should be X just from the P over Q is equal to R over S. This 2 ohm, 1 ohm, 1 ohm, 2 resistors in parallel, apply the law of parallel combination of resistance, the result will be 0.5. Here also 0.5. So what we have? This is the P, this is the Q, this is the R, this is the S. P over Q is equal to R over S when bridge is balanced. So P over Q means 12 over Q is this combination 0.5. Is R is 6 plus X. 6 plus X divided by this S is also 1 and 1 combination is 0.5. So this 0.5 gets cancelled. 6 plus X is equal to 12. So X is equal to 12 minus 6, that is 6 ohm. So answer of this is 6 ohm. Here we have choice to answer the one was, choice was 4 ohm, second was 2 ohm, 3 was 3 ohm, and 4 was 6 ohm. So the answer is 6 ohm. The fourth part is correct. We just calculated using the V-distance displacement. What we apply, that when the bridge is balanced means when the B and D both are at the 0, same potential, so difference is 0, then no current flows to galvanometer, bridge is balanced, the ratio of these resistances must be equal. So we get the answer X is equal to this unknown is 6 ohm. So, okay. Like this you can solve many problems. There is no limit of problem solving. You can continue to solve a problem, but this is not possible for me to do many problems. So I will do say one more problem. In a potentiometer experiment, it is found that no current flows through the galvanometer when the terminal of the cells are connected to 125 centimeter potential wire. In potentiometer experiment, no current flows in the galvanometer when the wire length is wire length we have 125 centimeter. Two ohm resistor when the cell is, the battery, the cell is shunted through 2 ohm resistance, the length of the wire becomes half. Half means 125, 5, so half of 125. Now find out the internal resistance. Of a set. So what we do? We just use the formula, well-known formula, that R is equal to E minus V over V into R, the shunt resistance. This is the formula. Apply this for internal resistance, and these are proportional to length. So E is proportional to 125 minus half of 125, that is 62.5. Divided by B, 62.5. And R is 2 ohm. So just, you can see. This is 62.5, 62.5. 62.5 divided by 62.5 into 2. So this cancels, so it was 2. Answer is 2. 2 ohm. That is the internal resistance is 2 ohm. I have choice of the answers. It was first was 2 ohm, second was 1 ohm, 6 ohm, third was 1 ohm, and fourth was 3 ohm. So there were 4 choices of answers. I get 2 ohm, so the first answer is correct. This way we can solve many problems. The problems are unlimited, and we cannot continue for indefinite period. So friends, like this, you solve more problems. I may stop today here. When I come again, maybe tomorrow, we will talk about some other topic, maybe about the transient currents or AC currents. So thank you very much for listening to me.